Hello, my name is Matthew Fisher. My partner is Benjamin Wagner. We're in the course MAE ECE 535, Design of Electromechanical Systems, and our project was to design an autotransformer. So what is an autotransformer? An autotransformer allows you to take a primary voltage and step it up or step it down to different secondary voltages of your desire. An example of an autotransformer would be a variac, where you can input 120 volts AC and then step this up or step it down by a knob to the desired secondary voltage which you desire. Another application is substation use for high power applications, and this is used to maintain a desired secondary voltage, which is then used in an autotransformer to counteract the changes in the primary voltage, which can be seen across the day. How are they made? Multiple taps can exist on one secondary winding. This tap is incrementally and very finely adjusted to allow you to choose a secondary voltage of your desire, which is an application of variacs. Another application would be different physical coils wound as secondaries on a particular ferromagnetic material. And these physical windings have different numbers of windings themselves, acting as a different source. Faraday's law of induction is the key concept for how an autotransformer works. When you have a time-varying current, this generates a time-varying B field. This time-varying B field then generates a time-varying flux linkage within the ferromagnetic material. And this time-varying flux linkage is capable of inducing a voltage across a secondary stationary coil. The key concept for magnetic circuit analysis is Hopkinson's law. And Hopkinson's law states that when you have a magnetomotive force in the presence of a ferromagnetic material, you induce a magnetic flux within that ferromagnetic material. MMF is measured in units of amp turns, which gives a concept of exactly how it's generated. It scales with current and the number of turns with relation to your transformer design. Ohm's law is an application on the secondary side, such that the change in current, which is linked by flux, it generates a voltage across the secondary coils due to resistance within the wire. Here's the design and layout of our particular schematic. We have two different windings on the secondary and one large winding on the primary. The primary winding is 200 turns roughly. The first secondary winding for 6 volts is roughly 100 turns. And the second secondary winding is roughly 60 turns for 3 volts AC. We have a resistor on the primary side of the transformer, which limits the current on the primary to help reduce heat generated within the primary side of the transformer. And this is to protect the enamel coating of the wire on the primary so that it doesn't short or cause any issues. We're using an LED as a transducer. This LED allows you to visually see the change in voltage in terms of a change in brightness. We have a 150 ohm resistor limiting the current to the LEDs themselves so they don't damage or become damaged due to overcurrent. And we're using 18 microfarad capacitor to help reduce ripple, a 60 Hz ripple which exists on the secondary sides of the transformer. Here's the references for our project. And next up, Benjamin Wagner will be doing the demonstration aspect of our project.
We chose to create a autotransformer that steps down 10 volts to roughly 6 volts and 3 volts. So if we look at our setup here, we have our power resistors to limit our current from our voltage source. We have our transformer, which has a primary, 2 secondaries. The primary has 200 turns. This secondary has 100 turns, and the second secondary has 60 turns. Now, to demonstrate the drop in voltage from our primary to our 2 secondaries, we have an LED wired to our 100 turn secondary and an LED wired to our second secondary, which is 60 turns. Now, to show the voltage that are being dropped, we have 10 volts roughly on the primary side. We have 6 volts on the 100 turn secondary, and now I'll switch the voltmeter over. So now I have the voltmeter on the second secondary. We have roughly 3.3 volts here. And to show the difference in the drops in voltage, we have our LEDs that are now lit. This one, the one on the right, which is a 100 turn secondary, is obviously brighter than the one on the left, which is the 60 turn secondary. That's our demonstration. Thanks for watching.